guys. So what we've been working with lately in the discrete class, we've been working with binary code. That's what we worked on the other day. And again, binary code, it's just one of those computer languages that's used where it's just a combination of zeros and ones, right? It's never, whenever we send things through a computer over the internet, it's never what we think, right? We always think that we're typing in words and those words are being sent the way that we see them, but it's not. Whenever you deal with binary code, just like we talked about the other day, we're dealing with just a combination of zeros and ones. That's how computers actually send information. That's the computer language that's getting used, right? So again, when we worked with it the other day, we had a combination of zeros and ones, right? And what we realized was that those numbers represented something, right? So let's say we had this, right? In order for us to figure out what this represented, what number it represented, we ended up looking at the pattern that existed with binary code, because it's always the placement that's there that represents a certain number. And if we have a 1, it means we have that value. If it's a 0, it means we don't have that value, right? So when looking at this, we ended up practicing, again, all review, where we always start from the right. The first one has a value of 1. The second one has a value of 2. The next one has a value of 4. The next one has a value of 8. And the pattern, 1, 2, 4, 8, it's always doubling, right? So the next one after 8 is 16. After 16 is 32. After 32 is 64. And after 64 is 128, right? So that goes with that, that goes with that, that goes with that, that, and that, right? And now it's just a way of us seeing it is what numbers do we have, right? And again, when we have this, and this pattern is never going to change, guys. Whenever it comes to binary code, you always start from the right side. It's always 1, 2, 4, 8, 16, 32, 64, 128. It's always doubling. If they gave us another one, it'd be 128 times 2, which would give us 256. After 256, you would double it again, and it would give us 512. Again, always doubling, right? So every time we see a 1, it means we have that number, right? So right there, we have a 1, so we have that 1. And it doesn't even matter. I'll actually start on this side. Since 128 is 0, we don't have that, right? Since 64 is 1, means we have a 64, right? Finish that. We don't have a 32 because it's a 0. We don't have a 16 because it's a 0. We do have an 8 because it's a 1 there, so always add them up, right? We do have a 4 because there's a 1 there. We don't have a 2, and we do have a 1. Okay? So all we did, getting the numbers, right? We had a 64, we had an 8, we had a 4, and we had a 1. And notice, we had 1, 2, 3, 4 ones. We have 4 terms. That's how it always should be, right? If we only had 2 ones, it means we should only be adding 2 numbers, and you always add them together. So now if we were to do it, 64 plus 8 gives us 72. 72 plus 4 gives us 76. 76 plus 1 gives us 77. So that's the number that we're dealing with. If you were to look at that binary string, 0, 1, 0, 0, 1, 1, 0, 1, that represents the number 77, right? It's just, again, getting practice. This time we're getting practice with bigger numbers, but we're also going to be focusing on something a little bit different today, where I want to see if you guys can get comfortable with this in actually, instead of being asked what number you have, actually being able to write the numbers yourselves, right? We're going to do a little bit of practice with that. But again, I just want to get you comfortable with this. Let's say I had this string of 1, 0, 1, 1, 1, 0, 1, 1, right? Let's say I had that, and same thing. I want to figure out what numbers I'm actually having represented, right? Again, always realize what it is. First one is a 1. Next one is a 2, right? That goes with that, that goes with that. The next one is a 4. Next one is an 8. Next one's a 16. Next one's a 32. Next one is a 64. And then the last one is 128, right? Again, just wanted to draw this just so you guys actually see the numbers that it goes with. Sorry that everything is a little bit stuck together, but when you actually have a bunch of ones, gives you less space above each number, right? So again, we have those right there, just to break it up. And again, I am sorry if it does look like that, but remember guys, just go in the order. We want to see what number that represents, right? And so the first one, I'll actually draw this in between so you guys actually see it better. Draw that there, draw that there, just so it doesn't look like a bunch of numbers, right? All together. There you go. So we have that, right? So the first one, 128. We have 128, so we put 128 there, right? Because it has a 1. That one's done. We don't have a 64. We do have a 32, right? We do have a 16. We do have an 8. We don't have a 4. We do have a 2. And we do have a 1, right? So again, good way to check. 1, 2, 3, 4, 5, 6 ones. 1, 2, 3, 4, 5, 6 terms. So we got that idea, right? We had the 128, we had the 32, we had the 16, we had the 8, we had the 2, we had the 1, right? If we start adding them up, 128 plus 32 gives us 160, right? I'm going to combine those just because it makes things easier now to see. I'm going to rewrite it. But again, that was just to make things easier for you guys to see, right? Because now once we have that, we now know 160 plus 16 gives us 176, right? Those two gave us 176. We're going to do 176 plus 8 plus 2 plus 1. 176 plus 8 gives us 184. 184 plus 2 gives us 186. 186 plus 1 gives us 187, right? Equals 187. And again, I wanted to get practice with getting you guys bigger numbers because I did want you guys to start seeing. Last class, I wanted you to just get the hang of it, just feeling comfortable with it. Once you felt comfortable, I want you guys to start seeing that even though it doesn't look like it, the numbers have gotten much bigger. Last time we were working with like 50, 40, all of that. This time we're now getting into the 180s, right? So we're getting to that point where this is, even though the numbers don't look like a lot more numbers, the numbers are getting much more significant. So you start to see how much easier it is for computers to send all this information, especially big numbers over the internet, online, you know what I mean? So again, this is all review. Just always get in the habit of always doubling. But now, I'm going to see how you guys feel with being able to actually express these numbers in binary code, right? So I've been giving you a string of binary code. I've been asking you guys to figure out what number that is. Now, what I want to do is, I want to give you guys a number, and I want to see if you guys can actually figure out what that number is going to be in binary code, right? So let's say we have the number 43, right? I want to write the number 43 in binary code. So think, the way that you actually do this, it's just practice, guys. It's us having a way to see how we can break that number down. So remember, in binary code, the only numbers that we have that we can actually break down is we have, here, I'll draw it this way, right? I'll make it as a table. So the only numbers that we have, and it always starts off, are the numbers that we saw in the pattern, right? So we start with the value of 1, the value of 2, the value of 4, the value of 8, the value of 16, the value of 32, the value of 64, and I wrote those to actually fill in the table, right? We want to see how we can actually write the number 43 in binary code. So we already know that in this table, there's one number that we cannot use. We know we can't use the 64 because 64 is already bigger than 43. Doesn't make any sense. So whenever you guys are actually trying to come up with the number that you're expressing, always try to figure out what's the biggest number that I want to start with. We know we can't start with the 64, so there's no point in even having it, right? But we do want to start with the 32, because 32 is the biggest number that's going to help us to get to 43, right? Think of it that way. So we know we're going to want a 32, right? So automatically, now you got to start thinking, from 32 to 43, what's left over, right? And if I'm thinking to myself, what's left over, we can do 43 minus 32 gives us 11, right? So we have an 11 right now. This is what's left over. So now from that, we need to figure out all of these numbers that are left over. Which numbers can I put together to give us 11, right? So now start thinking. We know it can't be 16, because 16 is already going to be bigger than 11. So it can't be that, right? We know that we can use an 8 to go to 11, right? So we know that 8 plus 2 plus 1 gives us 11, right? So now if we start adding all this up, we know that 32 plus 8 is 40. 40 plus 2 is 42. 42 plus 1 is our 43. And again, we don't have to count this number just because we always want to start with the biggest number that we used. In this case, biggest number we started with is the 32. If you actually wanted to, let's say, use that 64, you would just put a 0 there, because a 0 means we didn't use it. But you don't have to, you know what I mean? And now once we figured out the biggest number, everything else that's in between, we automatically put a 0. Put a 0 there because we didn't use the 16. Put a 0 there because we didn't use the 4. So the way that we would actually express the number 43 in binary code would be 1, 0, 1, 0, 1, 1. That would be how we would actually write 43 in binary code, right? And it's just getting the hang of it, guys. But usually, especially, if you can subtract that first number, the biggest number from what we have, that usually will make things a lot easier for you to see. All right? But again, let's try one more, see if you guys get the hang of it, and see if you feel comfortable with it, you know what I mean? But again, all this is just practice, guys, and it is interesting to see these things sometimes, how it's all used. Because up until recently, I never realized this as well. Everything's a learning experience, guys. Let's say that I wanted to use the number 50, you know what? Let's go bigger. Let's say that I wanted to do the number 73, right? Let's say I wanted to figure out what 73 is going to be in binary code. Again, for now, if it helps you guys to create a little table just so you guys actually see it, feel free to do that, right? Because sometimes it does help visually with just being able to see what you guys are actually looking at and what you're going to need, right? So the first one, 1, 2, 4, 8, 16, 32, 64, right? We have that. And again, you always go bigger, and it's always doubling. 1, 2, 2 times 2 is 4, 4 times 2 is 8, 8, 16, 32, 64, always doubling, right? So now, same thing we did before, let's do that now, right? We want to come up with the number 73. The biggest number that we can think of right now to give us 73 would be 64, right? Because 64 does fit into 73. So we know we're going to need to use that 64. That's the first thing. And the same thing we did before, let's subtract them, right? 73 minus 64 is going to equal 9. So 9 is how much we want to fill up next, right? So now, since we have 9 left over, we want to use all of these, whatever numbers are here, the remaining ones, to come up with 9, right? And this one should be easy to see because now, how do we make 9? From all of these numbers left over, all those values left over, how do we make 9? Well, we wouldn't use the 32, wouldn't use the 16, we can use the 8, and we can use the 1, because 8 plus 1 gives us 9. And now if we look at it, we have it, right? 64 plus 8 is 72. 72 plus 1, 73. So those are the numbers we used. The numbers we didn't use, put a 0, right? And we're done. The way that you would actually write binary code, 73 in binary code, would end up being, and let me write in blue just so it's not all the same color, would end up being 1, 0, 0, 1, 0, 0, 1. There's our binary code string. Again, when we look at that, we know that number there represents 73, guys. Always get in the habit of it, right? Any questions, guys, feel free to ask, but it is one of those things that's good to practice with. Take care, everyone.